Going live, and it says that I'm live. Excellent. Back once again. Okay. Couple things right off the bat that are of most importance. First, I had posted the homework that I wanted to post, but unfortunately, I posted it a little bit later than I wanted to. I'd originally wanted to post the homework on Friday, but I ran out of time. So ultimately, I believe I did post it yesterday at some point. Bless you. But as a result of me posting the homework yesterday, I specifically made the due date for that homework on Thursday rather than today. So there are a couple of worksheets that I uploaded with that homework that you can look at. And there are certain problem numbers that I have identified. Hold on, let's get the door. Yep. There are a couple of several problem numbers that I've identified, so please make sure you're following those directions. But yes, this will be due on Thursday. So please make sure that you are getting that particular homework done. For those of you in the chat, if you would be so kind as to leave a comment in the chat, that would be wonderful. So I can keep that attendance going, et cetera, et cetera, et cetera. Next week. What is today? I have you Tuesday, Thursday, and then I have you Monday, right? So then Monday, you all remember what's happening Monday. Full time, all day, yeah. 24 minutes. I can do whatever the heck I want.
Well, technically we're not learning any new information.
I can do whatever the heck I want. Guess how much they've told me? Accurate. Yeah. We'll figure it out as we go along. But keep in mind, just for you guys who are here, obviously if you're at home, it's a different situation if you're still virtual. But for you guys that are in the classroom, our class is going to be meeting much later in the day. And I would assume the hunger level at some point is going to be something else, right? You have lunch before? So you have it between second and third? Really? Oh, that's interesting. See, they haven't told me anything.
No, we like stay in classrooms and go outside.
Okay.
No, it's like a certain area.
I think you have to like pick a location and stay there.
Or a certain hallway.
Apparently, you guys have to like.
I'll do whatever I want. Anyway.
Like college, basically.
Yeah, college. Like the professors escort you down to the cafeteria. No, but yeah. So apparently, if that's happening, I mean that's going to be interesting. So then, thankfully, we will be coming in after you eat. Then, so cool beans. But we'll figure this junk out. It'll be a learning experience for everybody. Although, as I've talked about with other classes, just like, oh yeah, let's go to phase 3 with like a month left to go in the school year. Yeah. All right, but whatever. We'll figure it out. As for today. My goal for today is to review a bunch of the information that we have been doing. Specifically, I want to focus today on adding and subtracting these functions together. I have a set of problems that I am going to send to you via PDF in the Google Classroom stream so that you have an opportunity to see them close up and that you can copy them down and put your work in a different location, but we'll deal with that. But we are gearing up for an assessment. That assessment will be covering the first couple of sections of this brand new chapter that we've been working on with multiplying and dividing and adding and subtracting these functions. After this assessment, we are going to be going a bit down the rabbit hole with these problems, but you'll see when we get there. They're going to be fun, mainly for me, not for you, but mainly for me. You remember when I showed you those graphs? Yeah, those are going to be fun. They are, I shouldn't say fun in a certain sense. They are fun in every sense. But anyway, so what I'm going to ask of you is kind of twofold. Number one, if you do not already have those notebooks out and open, I'm going to ask for those to be out and open. And number two, because I'm going to be sending you this PDF, I am going to ask that you also have those Chromebooks out and open so that you can see the PDF. I will have them up here, yes. It's just that I'm going to post it to the Google Classroom just because it's not easy for everyone to see. I got you. So let's flip this camera. Actually, no, let me post the PDF first. Let's see what we got here. Subjects. Nope, not that one. That one. This, let me double check. Yep, that is the PDF for today. PDF for today. Post. And we are going to focus our attention on this. I'll open this in Lumen PDF. Continue. Come on. Boom. And there that thing is right there. Excellent. So this is what the PDF should look like right here. Zoom down a little bit. Oh, posted the wrong one. All right, let's try this again. I posted the wrong one. I'm going to delete that one. Let's try this one again. I know exactly where this one is. Well, now that I got the first one wrong. Let's go to the desktop. Upload to Drive. There, that one is. There is the PDF for today. Post. There we go. That one should work. Has to continue. All of these extra little clicks. And there we go. Perfect. So there are 8 questions on this particular page. Now, the important thing is that we do have the practical work to get these problems done. I want to walk you through the first 2 problems together with me. I want to walk you through these first 2 problems. And then I'm going to give you the opportunity to try some of these on your own. Try to push yourself to that level to see if you can handle these particular problems. Now, these problems should be theoretically fairly straightforward. There shouldn't be any crazy surprises in them, but they are supposed to develop the skills and understanding of getting these things done. So what I'm going to do first is I'm going to copy down the first 2 problems. Let's see here. I'm going to copy down the first 2 that I'm going to do with you. First of all, well, I'm going to call this in my notes, add and subtract practice. And let's see, the first problem, u plus v over 3uv minus 2 over 5v. And the second problem, 3 over 8x minus 3x. Okay, flip to right here. There we go. There's that first problem right there. Yes, they're using different variables other than x, and that can be frustrating. But, well, we have to get used to that kind of thing because they're going to throw it at us. When it comes to adding and subtracting these particular problems, when it comes to adding and subtracting these rational functions, you have told me in the past that we need to have common denominators. And yes, 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 we do. We need common denominators. But clearly, we do not have them for this problem. When that happens, you have to ask yourself the question, what do I need to put into the problem in order to get common denominators? I see a 3 and I see a 5. Okay, least common multiple, 3 and 5. What do we get? Least common multiple was stuff you guys did back in I don't even know, 5th and 6th grade. It's different from greatest common factor. Greatest common factor between 3 and 5 would just be a 1. But what's the least common multiple? 15. Now that's something we can start with. 15 is definitely going to be helpful here. 15 is not going to be the end-all be-all common denominator, but it will be helpful because I still have to deal with these variables. Both of these fractions have a v in common. Since they both have the v in common, perhaps I don't have to mess with it because it's just a regular old v. But this first function, this first expression, has a u in it. Here's what I'm going to have to do. 15 is definitely what I have to get these problems up to. 15 is what I'm going to get them up to. But I'm also going to have to account for that u. So here's what I'm going to do. I'm going to write another line of work right here. And I'm going to use a red marker here. So you can see that a little bit easier. There we go. Now I'm putting that in a different color so that it's a little bit easier to recognize what the heck is going on. But I multiplied that first fraction by 5 over 5 in order to force that 3 to become a 15. I'm forcing it to become a 15. As we said, the least common multiple of those numbers was 15 in the denominator. The first fraction already had a v, which matched the second one, but it also had a u. So I'm going to leave it be for the time being. In the second fraction, I needed to multiply by 3 over 3 in order to force that 15 once again. But that second fraction was missing a u. In order to have common denominator, I need to account for that missing u, so I multiply by u over u. If this is done correctly, then both denominators, after this multiplication takes place, both denominators should end up being 15 uv, which clearly they do. They both end up being 15 uv. They both end up having the same denominator, and now I can actually bring those things together. The thing you got to keep in mind, though, is that you have to properly simplify the numerators. What is one additional thing that I put into this middle line of work that wasn't there at the beginning? What is one additional thing that I put into the middle line of work, right in this line of work right here, this entire thing right here, that wasn't in the beginning of the problem? Yeah, that will be important. Parentheses. Parentheses will be important because now when you simplify this first fraction, you have to know that you are technically distributing that 5. You are technically distributing that 5, and you have to account for that. So this becomes 5u plus 5v. Second fraction, well, it's just a 6u. No harm, no foul there. But ultimately, they come together. The rules of adding and subtracting fractions is that the denominator stays the same. But now I can do that magical thing called combining like terms, where you have to think about this very carefully. You technically have a 5u minus 6u. A 5u minus 6u gets me negative 1u plus 5v. That 5v just comes over because it doesn't combine with anything else. This is the simplified answer to that problem. This is all that you can do to the problem itself. But Mr. Markey, can't you cancel out the 5 and the 15? No, you can't. Why? You can't because of the plus sign. That 5 has the plus sign separating it from the problem. The only way you can cancel out this 5 and 15 is if it was only multiplication division. Same thing with the V's, same thing with the V's, same thing with the U's. This is the simplified answer. There is an alternate way of writing it. There's one alternate way of writing it. This is that way of writing it. It's just changing things around like that. Either way is acceptable. You could technically write it as 5V minus U, and it looks a bit cleaner, but it's still the same exact answer. Let's try number 2. Now, after we do this problem, I am going to set you off on some examples on your own. I want you to try some of these problems to see if you can't get the work and the correct answer to getting it done. But this is number 2 right here. Oh, they both have an X in them. Yeah, they both have an X in them. However, you have to consider that 3x is being over 1. It's over 1. I can't do a reciprocal unless I am justified mathematically. Let me give you an example. Well, like that's 1 over 3x?
Yeah, but that would be like a negative.
Well, yeah, if I did this, technically, there would be an exponent on there. And I would not be able to combine them. I would not be able to combine them because that exponent prevents me from doing so. In fact, order of operations, I can't do that subtraction until I evaluate the exponent. I know. But that really just messes it up. It's like if it were equal 3x, now I do have a bit more of a justification to do something else. Maybe not a reciprocal, but now I have a justification to do some junk like that. But again, it's not equals to, you know. There has to be some level of mathematical justification. So I need common denominators. Well, it's a 1 here. This actually makes my life a lot easier since it's a 1. That's literally the easiest way to do this problem. The absolute easiest way to do this problem. Since it's a 1, I could do junk like that, which means this turns into a 3 over 8x minus something else over 8x, which I'll deal with that something else in a moment. Keep in mind you're multiplying together a 3x and an 8x. Please be careful. Please be careful. Now that you have common denominators, you could bring them together to be this. It looks terrible. In fact, the beginning of the problem was probably a bit more simplified, but this is what you need to have that final answer. Of course, again, you could write it as negative 24x squared plus 3, but that is an equivalent answer as well. If one of the denominators is a 1, it does make your life a bit easier. It really does. If the denominators are not a 1, then we're going to have a little bit of work to do. Okay. I want to give you a little block of time. Bring this open. Zoom in a little bit here. I would like you to try the next 4 problems. Numbers 3, 4, 5, and 6. I will give you 1 hint on number 6. The 1 hint that I'm going to give you on number 6, I'll write it in red, make it a little bit nicer to see. That's the 1 hint I would give you on number 6. If you factor the denominator on the left side, you find out that they both have a 3m already in common. They already have a 3m in common, but it is your job to force a common denominator. Now, because it's these 4 problems, because I want to see what you guys can do with this, I'm going to give you the next, I'm going to say 10-ish minutes, because I reserve the right to either extend or condense that time based on how well or not so well we are doing with these problems. But numbers 3, 4, 5, and 6, for those of you in the live chat, I had posted the PDF into the Google Classroom stream to make it a lot easier to see. I am going to copy that link into the YouTube chat. There it is right there. So that if you need to see that PDF, it is on that link in the chat. Let's take the next bunch of time. Let's get it done. Oh, I see what you're saying. You made the 3/6 a 1/6?
No, like I would.
You could, but here's what it's going to come down to. Ignore for a moment that this could become a 1/2. Ignore that for just a moment. If that were the case, those are your denominators. The minus sign will stay there. Just leave the minus sign there. Before, I don't have the example up, but before was a 3u. It's a 3b, right? Hold on. I will bring it up because it's easier to kind of visualize it. Boom, there we go. Here we go. Before, it came down to, okay, well, the 3uv is a term and it contains a 3, a u, and a v, right? It contained these 3 individual terms that were being multiplied together. Fair? And then over here, it contained these 2 terms that were being multiplied together. The reason why I want you to think of it in that fashion is because that 2n plus 3, think of it as a single term. A single term. Like the 6 is a single term. Well, this second fraction doesn't have a 2n plus 3. And this first fraction doesn't have a 6. That's kind of the process you have to think about it. Now, if you do think of it in terms of, oh, it's really just 1/2, that's fine. But the same thing happens. This first fraction now doesn't have a 2 as a single term. And this second fraction does not have a 2n plus 3 as a single term. You have to think of the 2n plus 3 as a single term. It's very strange. Oh, you're on this one?
No, I'm still on 3.
Oh, you said N. I'm sorry. I thought you said M.
So I'm just wondering, would those be like, how would I find the denominator? Should I just like go with this since 2n minus 4n would just be 2n? Should I just go across or should I try and?
Oh, I see what you did. Okay. You're treating the 2n plus 3 in the second fraction. I see what you did where I'll point to it. I see exactly where I'm pointing to. Right here. You actually had to multiply by a 2n plus 3 over 2n plus 3.
Oh, I had to do the whole thing.
Yeah, because the 2n plus 3, you need to think of it as a single term.
Yeah. And that's for both. Right?
Yes, yeah. It's a strange concept. It's like It's like I'm asking you guys to like write and speak in Greek. Yeah. When she gets back. Yeah.
From there, since it's 4M, 2M, should I just go across or?
Well, it should be a 4M. Watch. When you multiply that, you have to distribute that too. So it becomes 4M plus 6.
Oh, okay.
Yeah. So now that they both have the same denominator, now you can combine like terms in the numerator. You ever walk by a classroom in the middle of class time and you see a teacher staring out the window looking at you?
Yeah.
Not weird.
Yeah.
But I mean, like, I'm sorry, let me rephrase it. Not that they're just staring at you, but like literally like this staring at you. would like to slowly go through these questions. I've already written out all 4 questions, or the actual just questions themselves, not the work. But I've written all the questions out like this so that I can easily just move forward with them. I want you to notice something. I didn't notice this when the problem was originally generated using the website that I do or the program that I do. But if I didn't notice originally, oh look, the 3/6 is nothing more than a 1/2. So I'm like, well, that's just strange. Why don't we just make it a 1/2? Oh, sure, I'll just make it a 1/2. It doesn't actually affect the problem whatsoever to make it that 1/2. It really doesn't. But by making it that 1/2, it just might make my life a tiny bit easier. So I'm going to leave it as that 1/2. Here's what you need to recognize. There are parentheses around the top and bottom of that problem. As I was talking about before, that 2n plus 3, you need to treat that 2n plus 3 as if it were a single term. That 2n plus 3 unto itself is a single term that I need to deal with. In fact, this second fraction, the one that I'm pointing to, does not have a 2n plus 3. It doesn't have it. In order to get this problem done correctly, I would need to make sure that the denominator had a 2n plus 3. But in order to force that denominator, I need to multiply both the top and bottom to get that done. The first fraction doesn't have a 2. Ms. Markey, look, there's a 2 right there. No, I'm sorry, that's a 2n plus 3. It doesn't have a 2. It doesn't have a single solitary 2 to its name. So I'm going to have to multiply the top and bottom of that fraction by 2. And again, notice I put that in red so you can see the distinguishing, the distinguishment between the two things, between what I'm multiplying by and what the original problem is. The original problem is written in black, and what I've added in has been put in red. Again, notice the distribution that takes place. The top of the fraction versus the bottom of the fraction. The top of the fraction versus the bottom of the fraction. That's an n. There we go. That minus sign in the middle is just coming along for the ride. I will have to deal with that minus sign in a moment. And that minus sign is going to frustrate you. Let me repeat. That minus sign is going to frustrate you in a moment. But I'm just bringing it down for the ride for the time being. This is what should happen after you found common denominators. Now, when I bring them together, watch what the heck happens. Oh, you can't see it. Zoom. Oh, kind of see it. There it is right there. What the heck happened to that last fraction? What the heck happened on the right side of this problem right here? What the heck is going on right here in this numerator? Ms. Markey, you wrote out the 2n minus 4 exactly as the 2n minus 4 was written before. I get that part. But what the heck is that? Wait, say one more time? For the 2n, yeah. What happened with the 3, though? I made it a minus sign as well. Do you know why? It would have to be distributed. That's the part that's going to frustrate people. Oh, between the 2n and the 3? Well, it's no longer a plus sign once that minus sign gets distributed to it. It was originally a plus sign. No. Why wasn't it 2n minus 3 in the first place, you mean? Well, if I go back to the original problem. Oh, there's a walkie-talkie in the hallway. The only way that that would work, or I'm sorry, the reason why I made it a plus 3 was because of that original denominator and the fact that I had to do that in order to match it. Remember how I said to treat 2n plus 3 as if it were a single term? Listen to this. 2n plus 3 and 2n minus 3 are different terms. They are not the same thing whatsoever. You are to treat them as separate entities. So in this case, you had to multiply by 2n plus 3 in order to match that other denominator. But the direct consequence of all of this junk over here was because of that minus sign and the damage that it did over here. But you don't have to worry about the minus sign until the end. That's why I just brought it down for the ride. Ultimately, the simplified version of this answer could be written like this. Oh, can't see it. There it is. You could write the simplified version like this. There is one more way to write the answer, which is also perfectly acceptable. You could also technically write the answer like that. It's the same thing. It's just with the denominator factored. Not necessary, but something to look into, because perhaps something might be able to simplify down the line. Let's take a look at number 4. Well, let's take a look. This was number 4, right? I didn't copy it down wrong? Okay. Just like before, you have to consider these denominators. Now, that minus sign is sitting pretty for the time being. That minus sign is sitting pretty. We're just going to leave it as is temporarily. We're just going to leave that minus sign all the way down until we have to deal with it. But watch what the heck I'm going to do here. I'm going to write this out, and then I'm going to explain why I did it this way. Okay. Now, there's a couple things I want to say to this. First of all, those denominators you have to treat as single terms. It's a k plus 4. That's a single term. The 3k plus 5, treat it as a single term. They are factors in this whole game. The first fraction had a k plus 4. But that first fraction was missing something. What's up? Huh? Darren? Last name? Oh, yeah, Darren. I'm sorry. He's right there. Yeah, sorry. Yeah, I know. Well, I can have it on the desk and it doesn't fall over. I was like so confused as to what she said. I'm like, yeah, of course I have him. Oh, yeah. So now, I apologize. This first fraction had a k plus 4, but it did not have a 3k plus 5. 3k plus 5 treated as a single term, but it didn't have it. So in order to force a common denominator, I needed to give it that denominator. The second fraction had a 3k plus 5, but it didn't have a k plus 4. So I had to give it a k plus 4. But I'm doing it in that way where I'm not actually changing the value. I'm multiplying by 1. Now, here's a trick that's going to save you a lot of time and energy. Here's a trick that's going to save you a lot of time and energy. You don't have to multiply together those two things on the bottom of the fraction. You don't have to actually multiply the denominator. What you could do instead is this. the denominator could stay like that. Now, I'm going to have to do a bunch of junk to the top. But the denominator can stay exactly like that. I don't have to multiply it out. Leave it just like that, as two separate terms being multiplied together. What the heck was that? Somebody explain. What was that? Some video popped up. It did. What did it say? What did it say? Oh, about a bad song? A SpongeBob song? My word. Anyway, back to this. So watch what I'm going to do here. Check this out. Now, I'm doing this the long way. Check this junk out. I am doing this the long way, but I left those in different colors so that you could see what the heck is going on here. When I bring those denominators together, yes, those two terms, they have common denominators. I bring it together as a single fraction. I am not done with the problem because I still have to simplify, but I needed you to see this in a different color so that you can visualize what the heck is going on here. Yes, I'm going to have to multiply these two things together, and I left them separate colors so that you could distinguish them. Yes, I am going to have to multiply these two things together, but I left them separate colors so that you could distinguish them, and I just brought the minus sign down in between them. This one, not as much, but I'm trying to show you guys the process behind it. The reason why we need to be able to get this kind of stuff down is for when we get to graphing. When we get to graphing, there's a couple of first steps that you have to take when you get to graphing. Number one, if you have separate fractions, you have to bring them together into a single fraction. And then number two, factor if you can. But this skill will translate directly to graphing. Now, when I say factor if you can, don't multiply them back. Don't multiply them back together. Don't. Leave them separated. Leave them factored. Because in graphing, the next step would be to factor whatever you can. So it's already factored. Don't do the extra work. But I do have to simplify the top. And like I said, I kept them separate colors just to kind of distinguish. Now I'm going to have to simplify the top, the numerator. Let's see. This will become a 6k squared plus 10k. Now notice you're not just distributing a 3. What are you distributing? A -3. Make sure you realize it's a -3. Minus 3k minus 12 over this junky thing right here. I got to combine like terms. When I combine like terms, this will become 6k squared plus 7k minus 12 over this junky thing. I want you to notice something. After I found common denominators, after we went through the process in red, forcing the common denominators, what happened to the denominator the rest of the way out? What's happened to the denominator after I found its common form? The secret answer is nothing. Nothing has happened. That's a K right there. It stayed literally the same the whole way through. Now, here's going to be the key. I mentioned before that this is going to translate to graphing. And I said with graphing, you're going to have to bring together different fractions by adding or subtracting. But then I said, ooh, then you're going to have to factor. Well, if the numerator here were factorable, you would have to factor it. But it's not. It's not factorable. That is the final answer right there. If it were factorable, we would have to factor it. And we will see future problems like that. Number 5 is almost exactly the same. Number 5 is literally almost exactly the same. It's probably slightly more straightforward. I'm just going to walk you through this one for the sake of time because I want to get to that last one. Treat the x minus 3 as if it were a single term. Treat the x plus 4 as if it were a single term. The first fraction doesn't have an x plus 4. And since it doesn't have an x plus 4, I'm going to give it an x plus 4. The second fraction doesn't have an x plus 3. So I am going to give it minus 3. X minus 3. Because by doing so, I am forcing common denominators. It's the same problem, just with smaller numbers and actually less variables. But I am forcing both denominators to be exactly the same. I am forcing both denominators to be an x minus 3 and an x plus 4. Keep them separate. Don't worry about multiplying them back together. It's to your benefit to keep them separated. Then I'm going to have to do this junk. Now, I'm writing this out long ways. I'm writing this out long ways so that you can visibly see what the heck is happening. But you could theoretically save yourself time and energy and get this problem done sooner. But this becomes a 6x plus 24 minus 4x plus 12. Again, the denominator stays the same. I'm going to have to combine some like terms up there in the numerator. But ultimately, this is all I can do to the problem. Finding that common denominator is important. Finding that common denominator is vital. Bringing these two fractions together into a single fraction is going to be paramount for what we are going to do when we graph this thing. How would I what?
How do you plot that?
Oh, graph it, you mean? That I'm not going to explain just yet. There is a process. There is a process. But I'll give you a small hint. Most of the ordered pairs that we're going to find, we're going to get on the calculator. The calculator will give them to us. But it is going to be our job to calculate the locations of the asymptotes. We will have to calculate asymptotes. We will have to calculate x-intercepts, but the calculator will give us the rest. You'll see. I don't want to give anything away just yet. My main focus is just on this right now. Last problem. And I wrote it down differently because of what I explained when I gave you this problem. Let me flip back. If you look at that bottom right problem could be factored in the denominator. And I factored it to look like that. And the reason why I factored it to look like that is because I need you to recognize this. The denominators both have a 3m. They have a 3m in common. The first fraction has an m minus 3. Good for it. But in order to have a common denominator, the second fraction also needs that m minus 3. It needs it. When you bring them together, the denominators will simply be 3m times m minus 3. Boom, they both have the same denominator. Your job is to clean up the numerator. I'm going to bring it together like this, that 2m minus 3 doesn't change. It's a 5 right there. So plus 5m minus 15. Thankfully, it was a plus sign in between, so I didn't have to distribute a negative. I was distributing a positive. Ultimately, I get 7m minus 18 over that junky thing. Once you find the common denominator, the denominator, for the most part, will stay the same. There are few exceptions. Few. But your job would be to clean up that numerator after you get those common denominators. You have a homework. It is due on Thursday. Please make sure that you are attempting these problems to the best of your ability. As with all of my official homeworks, quote unquote, it is graded on completion, not correctness. Don't try to fake your way by just using a website to do the problem for you. See how that turns out when you eventually do my Edge Elastic assessments. Take your time with them. See what you can do with them. Email me if you have any questions. Bell's going to ring in a few moments. If you haven't left a comment in the chat, please make sure that you do so, because there is the bell. It probably is the most complicated in the sense that it's taking a lot of past skills. And when I say past skills, I'm talking like 5th and 6th grade. And it's bringing them back to like a higher degree. I know. It's one might argue that exponential